Riemann sum, they're the worst and the best thing that you could possibly think of because, well, I learned that recently. I mean, not recently. I mean, on a freaking test, I had to do a Riemann sum, even though I thought I was over it. And yes, that was a pain in the ass. Uh, so I think it was last quarter actually, so it really wasn't that big of a deal. But this equation here, I don't recommend you get a definite integral with it. You could definitely do what's the word indefinite integral would be easy, just infinity to infinity. That's oh wait, that's a definite integral by infinity to infinity, which oh wait, that's a definite integral. Never mind. That's well, maybe it's actually impossible to do. Is it possible? Actually, I wonder. Lambda 5, because these don't matter, they're constants. These don't matter. E negative lambda. Well, actually, this is not that bad. You could probably do something like di 5 times, which is integration by parts 5 times. Uh, I thought it would be worse. No. I'm wrong. I'm wrong. So this equation would be actually positive because what we have here is negative lambda over here. Oh wait, is this minus one also included here because it's inverse? So actually, it would be e negative lambda minus one negative one. Okay, maybe it's a little bit harder than I thought. Okay, fine. I was talking about being the sum anyway. So um, this equation is for energy, I believe, and it is basically does this, and then what you want to do is do 0.1 and then times it by this and just do even sum. Oh, which is fine, but I realized then that I skipped leaving the sum because I left it as this originally because I thought they were useless and a waste of freaking time. Um, but recently learned that they're useful, so I put them in here. I know Riemann sum; they're very easy. They're not hard. They're just summation in the weirdest way possible. Um, Now, change of x equals b minus a divided by n for a definite integral. I still don't know. I do know, but yeah, if you look at this and go limit of n goes to infinity, that pretty much goes to zero, right? If you take a limit of that, that's the whole point. That's the whole point of that. To get infinitely small intervals. And then the more small you get, the more correct you get, blah, 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 blah. So now let's actually talk about the real function over here and why it's a little bit weird, I have to admit. You instantly get this one, but how do you get xi? And xi actually has more than one definition. It has three definitions, and they have all reasons to believe it. There's three left hand, right hand, and then left hand minus right hand divided by plus plus equals middle. Um, or actually, as you'll find, let's do the time frequency system where it's u of t, which means that it starts at t equals zero. It's causal, and actually, I don't think at this point in time you should know any of those terms. So I'll shut my mouth. So let's just say the original it gives you a discrete value. Um, and actually, maybe you shouldn't even know that either. Um, it gives you this function over here, and then well, why don't we say we change the linear over here, and then for some reason we have an absolute turn, and then we have something like this. Um, And you want to get an integral of that, which is the area, but the integral is actually tiny bits of area, so uh, you might not need it. But let's go with let's denote left hand as that. The left hand with this color. Wait, I'm using the worst brush. Let's use the blue as this color. So why don't we say we want it to here, this integer. So n equal this integer. I don't know. Let's just say this was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Let's say this equals 13. Okay, good enough for me. So let's just do right hand. Did I say left hand or right hand first? I don't know. Right hand. Okay, right hand. All right. So the first one's over here. So actually, I'm gonna erase this part over here because it's not useful. Um, and then we'll do left hand to over here. That's pretty much what you have to do. And then left hand to over here. Left hand to over here. Left hand to over here. Left hand to over here, 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 and left hand to over here. Because this is how real data looks like. And then the right hand looks over here, 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 looks over here. After this, I want pasta. I'm gonna actually make pasta after this. And also, I need to clean my room. My room is a freaking mess. Uh, anyway, over here, over here, over here. Actually, this part's not necessary. We're just gonna get rid of that portion. Looks like we don't need that. Good. We're getting rid of it. So let's just say this is extra data, whatever. Listen, actually, I don't want to confuse people with that. With extra data, we know it's causal, so we know. Let's just say that because we know up to b, everything after flips on itself, and we know it because it depends on the previous. Because we know it's causal. Okay, so we can just say that. So the area of this, 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 this is all uh right-handed thing. And then actually we need to get rid of this part because there's no need for that. And then let's just say the left-handed integral now. No, the Riemann sum, not integral, is here, 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 and that sounds good. This sounds that sounds weird. Okay, so they kind of look like green a little bit. Fun fact: when I was a kid, I could not tell green from blue, which is quite common. Actually, it's pretty normal. Um, um, so it's just very awkward. And then I realized I can tell green from blue later on. Somehow it changed. Anyway, so what the midpoint does is get the slope like this, like that, like that, and then like that, this, like this, like this, like this. This is midpoint. To be careful. Okay. So, uh, sure. That sounds correct. That looks correct. That's pretty much what we did. And obviously, if we add more points here, more samples, we can get a better picture of what this looks like. Excuse me. But we don't have better samples, so this is what we get. Um, And that pretty much is what Riemann sum is. Now, this, oh wait, I need a function here. This function has an I in here, which means you cannot just plug in like if this was t equals 0, that is 0, even though that is true for this case. Um, or if I equals 0, it means to plug in 0, or I equals 1, it doesn't mean that. You have to say, let's just say this is 13, right? Actually, let's just say that's 2 now. N equals 2. Uh, and then what this is separate to 13, so actually have to divide it by 13. So we start at a, which is then turn into 0 0 I equal, let's start, actually let's split this in half and just say this is a, this is the start at I equals 0. So over here we know that this is when this happens, 2 divided by 3, so that's this 1 2 3 4, so 4. So this is 8 13, I think that's where this is. So that would be the start, and then you would have to keep on adding it. It might not make sense, but let's just look at the left hand. The truest definition of left hand is a limit of n equals to some number, so let's just denote by number symbol, um, and by the function of the what was it again, a. Um, I did not explain A at all. So in integrals, we have conventions where this is the truth, but some people do BA, which is not conventionally recommended. Um, so what does A mean? A means the left hand of the start, and then B means the right hand. It doesn't mean 0, and then this could be 0 over here, and then the integration starts at this point. So it is looking for all the information in between those two. So A is the left hand, and that's pretty much why A is starting. Then B is the right hand, um, right left hand, right? Yeah, right. And then so we add when we do this, and then we just do change of x, change of x. So why do we do that? We want the f increments to be infinitely small. So actually, the truest definition of SI, well, it's very confusing, but there's two definitions, which is if this limit goes to infinity, these would those would actually, sorry, summation over here, summation over here. So yeah, uh, because of the summation, they would equal each other, but they don't actually equal each other yet. So, but xi, that's why xi is xi, because it could be a plus change of x, and then this xi can be equal to b minus x, but xi does not equal xi. These two don't equal each other. It's just that it denotes that if you summation it, it would equal each other. And I forgot to write the summation here, which number over here, and then I equal 0, and I forgot to add an I here. So sorry about that. That's actually my fault. So summation I equals 0. Let me rewrite it for before it. A plus change of x I, change of x, and then so the right hand would be equal to lim, because it kind of is obvious what would it be, because it's b minus change in x I, change in x. So we have both of them, and now we finally know the final stage, which is this. Uh, Actually, I'm thinking about it. We should rename this to something else. So I think this is the left hand. So why don't we call it left hand? Then let's just say left hand. Then let's just change this to. Oh wait, actually we can't do that. Okay, so we have to write it like this, and then right, and then right. It makes it more clearer, more looks cooler also. So you can see what I did here. It's pretty much all I did. And then let's denote it over here. Let's show it off. So when it's zero, obviously it doesn't do anything. When it's one, as you can see, the best estimation over here is this one over here, which is 10. These are bad estimations. Oh, by the way, if you go to infinity, it really doesn't matter, as I can see over here. If I get a very large number, they equal each other no matter what. So who cares at that point? And actually, I think I like whatever. And you keep on getting better estimation as you keep on going. Actually, maybe I can play this a little bit. Ooh, nice, cool. That looks great. And then the best one is when what's it doing? He bet 10. So let me just revert it that back to A and B, just in case it breaks. All right, and obviously this is what we're looking for over here, the area in here, which is clear as day. Now, we can do all of this, but we can also just do an anti-derivative, which is just this, the inverse parable. Yeah, you can just do inverse parable. Why not? I thought Riemann stones were useless and a piece of joke and trash, but it turns out it's literally one of the most important thing in all of operative. I learned that the hard way. Um, the limit definition really doesn't matter, but what I mean by that is like there's certain. There was a test question where I just had where I was saying, "What the hell? This doesn't even look like a test question for advanced thing. You just literally had some kind of function you were drawn, and then you don't have to even draw. You just have to get data points like this and just do it." And I was just saying that doesn't look hard, and I was just saying, "Yeah, it's not. It's just doing this." And I was just saying, well, this is advanced calculus. Well, it looks not hard. Well, you know, that's pretty much. It's weird. I know it's not hard. I mean, I thought more advanced you get. It is harder. The math is harder. It's just the calculus just turns into a easier calculus, I guess.